we're going to be solving a problem of demand forecasting. Looking at this data set that is presented before you at the moment, so this is for a business that has several products, and each products are kept in an inventory. So the SKU is the store keeping unit. So this is the store keeping unit ID of a particular product. And the business has different stores. You can see 8091, 8095, and so on. And so these are different weeks. Stock keeping unit ID of the particular item on the inventory, the total price that was gotten for this particular store and for this particular product on that inventory, the base price, and if that store keeping unit item was actually featured, displayed, and the unit sold. So meaning, for each of these weeks, for each of these store, what was users or customers, the business customers buying behavior of each of these items on the inventory for the various weeks, and how many units did the users buy. So now, by analyzing this past transaction, we can predict a futuristic occurrence for a store, a known store, and a known store, provide the store keeping ID, the total price, the base price, if it was featured, and if it was displayed, and we'll be able to forecast users' demand. Now, this is very useful for some businesses, so you can know what amount of goods should you provision in some of your stores. You can know the number of resources you need to deploy at those stores. You get to make data-driven decisions and not acting on impulse, so you can maximize an interesting experience for your end customers. So let's go ahead to build an AI model off of these data sets. Demand forecasting. So we hit project, and we create a data set, a project, and we'll call it demand forecasting, and we get this project created. Now, on Autogon AI, there are two products you could use to build powerful machine learning models. There's the Autogon Studio Wizard, and there's the Autogon Studio. Now, Autogon Studio Wizard is an auto ML tool. You can build powerful models off of your data set in just 3 steps, whereas Autogon Studio, you have full control over your data preprocessing steps, full control over the kind of algorithms you want to run specifically from your data, full control over pipelines. So you can decide to build machine learning models or deep learning models of a particular algorithm. You can build from simple to complex neural networks off of your data set using Studio. But for the sake of this tutorial, we are going to be building first with the AutoML Studio Wizard, and when we are done, we're going to be building from Studio. So we'll quickly launch, and so it tells us to select the data set. So it fetches all available data sets in our account. We select demand forecasting. Now we give this some seconds to load up. Okay, beautiful. Now this first phase already shows us some interesting statistics about our data sets. Already we can already see this importance column. We can already see how the level of importance of each item on the column. So we can see the store ID, the storekeeping unit ID. We can see if it was featured has a very strong importance, and what is the base price and the total price have very strong importance down to units sold. Now we can see also that units sold, our target variable, what we are trying to predict is actually a numeric data, so meaning of numeric category. So meaning we are not going to be using a classification, we're going to be using a regression. So we use regression to predict continuous variable. So let's proceed towards building the model. We click on this next button. We select a regression because it's a regression problem, like I've just explained. We select the unit sold, so we are wanting to understand all data pattern behavior as regards the unit sold being the target variable, because that's what we're going to be predicting for when we are wanting to stock up for that particular store next week, or make whatever strategic management decision for that particular store. So we'll call this demand forecast, and we hit on train, and we'll give this some seconds to run. So this is how seamless it is for you to make data-driven decisions off of your data set, and you can do this seamlessly on Autogon AI. You don't need plenty years of experience. You don't even need to have any technical prior experience. You can, in 3 steps, make interesting data-driven decisions. So let's give this some more seconds to run. And we can already see the error plots, and beautiful, we can see the lines of y pred as to y, and we can see that the margins are very closely tilted, and we can see our arrow squared of 0.77, which tells us that this is a very highly performant model. And we can see the loss here, it's low. So we can also hit on feature of importance as to what we are trying to predict, and we can see the store ID, the SKU ID, total price, base price, week record IDs, feature. So all of these things, but we can see the stores actually matters. So meaning, so on based on what we're trying to predict, being the total price, some of the stores are having the highest margin, probably because of the location, or wherever. So so the next thing we're going to do right now is we're going to run some predictions for new observation and see what our model is giving us. So we hit on the predict, and good thing, I'm going to show you how to run some predictions off of a data set. So let's view our data set again. Now these are various past time observations. So one of the things we're going to do is we're going to run prediction from past observation, like this guy now. Record ID, week, this store ID, SKU, total price, base price, and all of this down to units sold. We are going to pick all of these things aside units sold, and we would inference our model to see what our model is going to predict. So by the time we're done with this, we are now going to try out new observations that are entirely out of this data set and see what our model is going to predict. So good stuff. Now I have the data set opened in a raw format, so you can see the same record ID 1. We're going to be building. So what we do is so we are going to pick record ID 1 aside the units sold. We're going to pick all of these things and use it to interact with our model. On Autogon AI, Autogon AI, the model doesn't take these strings like this directly. You will need to convert it into an acceptable data set. Okay, so we hit on whatever project here, select, and we'll click on the create data sets. We enter all of these that we've copied from here aside the units sold, and we select one dimension and we generate a dataset. We'll copy this dataset URL and we input it down here and we predict. So the goal is to see what our model is going to predict. So our model is predicting what is going to be sold for this particular record on this particular store is going to be 46, but we can see right here what is actually sold was 20. Let's do another one. So that's why it's having an accuracy of 0.77. So let's create another for one dimension, and we copy this and we take this right here and we run an inferencing, and our model is predicting 115, and what is the dataset saying? 120. So we can see this is very close. So our model is actually doing a very great job down here. So let's take another record and we create a prediction dataset out of it. Copy this, take this down to test dataset, and we'll click on the predict. And our model is saying this 57 is predicting a 57, but if we look at the dataset, 40. Okay, that's close but not so close. Let's scroll a little downward. We can pick this for this particular week, and let's create a prediction dataset from it. Generate this, copy this down to test dataset, and we'll run a prediction. And our model is saying is predicting 144, whereas it's 170. So that's far. So let's run two more from this existing dataset, then we will try out for a dataset that is out of the trained observations. Okay, we'll copy this and we'll place this on test datasets, and we run this, and our model is predicting a 37, whereas it's actually an 18. And the last one we pick for this particular store ID of 73, and we create a data set, copy this, I will take this to our test data set and run a prediction, and we can see our model is predicting a 56, whereas the unit sold is actually a 73. So beautiful. So we've been able to build an AI model of our data set, but with an accuracy of 0.77, which is actually a 77%. But yes, we can boost this accuracy. I'm going to show us how. We are going to use our studio environment as well, where we do some data pre-processing ourselves, and we see how we can boost the accuracy of our model by trying out some model algorithms and looking for the one that comes up with the best accuracy. Good. So before we hop over to the studio environment, where we have some more flexibilities, we can create a pipeline here, and I'll call this demand forecasting W. So demand forecasting with Studio Wizard, exactly. So I'll create this pipeline. Now I'll show us how to inference our dataset using the pipeline. Demand forecasting, leveraging Autogon Studio Wizard. We're going to build it right now off of Autogon Studio. So we have built this using this dataset. We've built an interesting regression model from Studio Wizard. So here I'm going to be showing us how I've built the same thing. You're going to be doing it yourself as well using Autogon Studio. Yes. So now if you look at this dataset, now when you're working with Autogon Studio, the first thing you need to drag is the data input, and whatever you drag in here, So you drag, you select the CSV, input your dataset URL. When you execute this block by clicking the run, if you come to the variables folder, you'll be able to see whatever has been executed. Now, this is the dataset. Now, there are two ways we can go about with data preprocessing of our datasets. And so for the sake of this video, I used Autogon automated data preprocessing. But before I go to this block, let me explain these two quick blocks. Now, this dataset has record underscore ID. This is like serial incrementation of database numbers. So I had to kick it out. So it has no impact on our model. So I took it out, and the way to take it out, I brought in drop colon. I specified index 0 on the dataset. And if you look at the output of drop column, after taking out index 0, you'll find out that it's then started with week as to what was here that started with record ID. Oh, beautiful. So after drop column, then data encoding. So there are two ways you can handle this particular week variable. You can actually split it by year, month, day, and have each of these things on different columns, or you can actually encode the values. So yes, I chose to encode the values. So I dragged in data encoding, and I selected string to hash, and I specified index 0, which is now the first, and I ran it. Now, why I brought in save name on Autogon AI, if you are doing some interesting data preprocessing moves, and you are going to build a pipeline off of it, it is important you save the weight of that data preprocessing step. So all data preprocessing steps that are important to be applied on the pipeline, you will find the name save weight down there. So that's save name, that's you enter the name of the weight that you're trying to save. Then I brought in data preprocessing. Now, you can do the same data encoding here, but I just chose to do it right here. Now, on automated data preprocessing, so here I specified the splitting. It was an interesting function of Autogon AI. So it combines 3 to 4 steps of data processing steps. So you can see this is a feature sampling step, splitting data set into X and Y variables. This handles for missing data, and I selected mean here. This handles for data splitting. So instead of me dragging data splitting, so I did that here. Then there are now some more steps like the encoding. So default it handles encoding. So it checks where it sees categorical variables of just 2. It uses a label encoding. No more than 10, it uses a one-hot encoding. You can exclude columns and do all of these things using the automated data processing, but I left all of these things default. And yes, again, I saved the weight of the automated data processing. All you need to do is enter any name at all and run it. So it runs this configuration on the data set, and it saves the weight based off what you've applied here. So if you check model and weight, you will see all the weights that has to do with this project. I've saved it here. And you can also see all the models I've built off of this project. We have it here as well. Cool. So if we look at feature scaling, after the automated data processing, I called in the feature scaling block. Now, if you look at the output of automated data processing, you can find the X train. This is because there was a data split. Specifically, if we look at the X train and the X test, we'll see that there are some heavy numbers, like the encoding we did, this other value, this other value, this other value. These are heavy numbers as regards this, and the model might be biased towards these numbers. So we had to bring in the feature scaling, and we block and we passed in X train and X test, and selected all boundaries. And again, we have to save the width. All boundaries means column, comma, column, meaning we are saying all rows and all columns, scale every single thing. And if you now check the output of the feature scaling, and if you look at X train, you'll see that the feature scaling block algorithm has actually scaled all components of our data set, which is beautiful. So the next thing now is regression. So now we dragged in an automated right here, automated, so you can see regression automated machine learning. Yes. So now what this algorithm does, it runs multiple regression algorithm and selects the one that is most optimal. So yes, it runs it with the time frame actually specified for it, and time frame for each particular execution that you're looking for. So now let's look at the output of this. It brings a sprint statistics and a leaderboard. So it ran a total of 15 regression algorithms, and you can see this is the metric arrow 2 that was used. And if we look at this further, okay, all these ones we don't need. Okay, yes, we can see best validation score, and we have the best validation score of 0.78, which is pretty interesting. Then we can also look at the leaderboard. Oh, for here, we won't say anything much for now for this particular algorithm. Great. So we dragged this, then we also dragged the predict. Now, this because we're now wanting to apply the model that has been built from here. So now here we call the model ARM. So that's why we had to specify ARM here again, ARM here. Default is so we can inference the model that was built here. So when you leave here blank, you are telling Autogon AI that, oh, I want to use the X test. But if you have your own data set, you can specify it here. So good. So we ran this and we generated a Y-pred. And now we have our own Y-pred as against the Y test. Now what the predictor has simply done is there is an X test and a Y test. Now our model has learned of the X train, and what we've done by predicting here is to predict the X test to try to get the Y test using our model. So you can see from the Y test we have 7, 17, 16, 20, 2, 9, 7, and on the Y pred, oh sorry, that 7 is not supposed to be there. 23 here was 17, 28, 32, 3, 1, 2, 42, 0, 1, 2, 3, 4, 5. So index 5 is 52. If we look at 0, 1, 2, 3, 4, 5, index 5 here is 26. So our model tries to predict the X test to get the Y test. So now for metric, so we drag the metric block as well, and we ran the metric block on this model to get our model accuracy. And yes, we got an accuracy, an R2 score of 0.68, almost 0.7, which is fair, but yes, not good enough. So one of the reasons why our accuracy is not very good for this particular data set, it's actually a synthetic data set. It barely has, meaning it's machine generated, it barely has correlating properties, much correlating properties. It barely models a real human behavior. It's just machine random number generated. So yes, so that's why we can see the lower accuracy, but it's fine. It actually works. You can replace with your own real data and get very accurate results. So yes, we have an R2 score of 0.68, approximately 0.7, which is beautiful. But don't forget that we built this same project, this same data set using Studio Wizard, and we got an accuracy of 0.77, almost 0.8. So meaning for this particular data set, for this particular problem that we're solving, the Studio Wizard accuracy actually beats that of the studio. Yes, you can try out yourself. You can try out XGBoost. You can try out random forex regression. You can try out build some neural network here and even leverage some automated neural network, structured automated as this particular guy. Bring this init, bring the train, and bring the evaluate. So you can leverage auto-structured data regression train that builds a neural network for you. And you can try it out and you can get a much more higher accuracy. You can even try to denoise the dataset. Yes, leveraging principal component analysis, and you denoise the dataset. Beautiful. Okay, so the next thing I'm going to be showing us is how to inference your model. We need to go ahead and build our pipeline. And to build our pipeline, you want to take note of all the steps taken to build that we ran to pre-process our data set. So these are data sets. So we dropped column. So drop column is going to come first at index 0 of data set. Data encoding at index 0, and take note of the model, the save name, automated data preprocessing, and feature scaling at all boundary, feature scaling underscore W2. So we simply come and we can then create a pipeline underscore W2. You can use any name at all. We drag in drop column, and at 0 we select drop column at 0. That's the first thing. The second item was data encoding, and we encoded weak value at 0. The third item was automated data preprocessing, and for X, and this was the weight we saved. And the next item was feature scaling, and then we scaled for all boundaries, remember? Yes, so we scaled for all boundaries, that's column, feature scaling underscore W2, and the next thing was model predict. And the model we built off of Studio, the name is ARM. So yes, we select ARM and we run save. So that's all we need to do in building a pipeline. So we'll give this some time to run, and beautiful, it's done running. We can then switch over to our project, and now we have our pipeline. So we're going to navigate towards quick predict and inference our model via our pipeline, and we're also going to try to inference our model via an API. So this is the quick predict page. I'll select demand forecasting. ARM was the model we built, and create data sets. Yes, this is our data set. We can try to inference for this period. When you are inferencing, yes, so this was the unit sold, and these are all the other records aside the unit sold. Now you are not to supply the unit sold, we are predicting the unit sold. Good. So we're going to copy this like this, yes, and we dump it on our model to inference it. But on Autogon AI, we need to generate a data set off of what we're trying to predict. So I've placed this in, and I selected one dimension. And beautiful, I have my data set. I copy it, and I drop an input link, and I can then run my model. Now, when I select the pipeline, we have the pipeline W2, which we have just built, and we also have DFW underscore 2, which was also what we have built also from the Studio Wizard environment. So we built a pipeline here and we built a pipeline there. So we are going to inference with it too. Don't forget that the data set we copied, the unit sold for this particular transaction is 7. So we're going to inference with the both pipelines and see, because the both pipelines are talking to different models. So we'll first start with the studio model and we'll see what it gives us. And it gives us 11. Beautiful stuff. And so let's try to inference the same thing, look using the pipeline built from Studio Wizard, and let's see what it gives us. And it gives us a 9. So you can see the Studio Wizard model is actually even more accurate, 0.77 as against 0.68. Good. Now that you've seen how to inference your model from Quick Predict, it also shows that you can inference your model from a Postman. So I'm going to quickly open up my Postman collection and I'll update the data sets. This is the data set I'm trying to inference. This flow ID is actually your pipeline ID. So I'll actually, to copy your pipeline ID, when you navigate to your project, open your project, you see a list of pipelines. So if I copy, this is the pipeline for Studio Wizard. I copy this and I paste this here. Okay, and I run this. Beautiful. So we can see this is a prediction, the same prediction that we've gotten. And if I load it up, I can see straight away the 11 that was gotten via the portal as well. Thank you very much. So this is how you can build an interesting model in split seconds leveraging Autogon AI, and you can inference this model right away.